Hello everyone, welcome back to another awesome video. In this video, as I've already promised earlier, that I'll be continuing my series on design patterns, and in this video I have came up with yet another awesome design pattern that is very common, very popular, and it has been implemented in various frameworks and programming languages, and it is called the prototype pattern. Now, what is the prototype pattern? Again, the prototype pattern, like any other design pattern, tries to solve some object-oriented problem, right? And it falls under the creational design pattern. So, as you've already seen from the title, so this means that it is solving a problem related to the object creation, right? And if you already don't know what creational design patterns are, I've made a very extensive video on creational design patterns and the type of problem they aim to solve. If you want to take a look at that video, you can just go ahead and take a look at that video and come back to this video so that whatever I will be explaining in this video will make more sense to you. Other than that, the only prerequisite for this video would be object-oriented programming. So hopefully you're already familiar with the basic object-oriented approach of solving problems, so that this video will make a little bit more sense to you. Okay, so without any further ado, let's get into the problem. Okay, so before we actually understand what the prototype pattern is, let's try to build a scenario. Let's try to assume a scenario or imagine a scenario where the prototype pattern will be applicable. Okay, so I'm just going to quickly drag and drop this square, and let's just call this a shape object. Okay, so let's think of a scenario where you're building a drawing tool. Okay, you're creating a drawing application where you will allow your end users to create multiple shapes. Basically, your end user can basically drag and drop circles or squares or maybe polygons. So this editor is going to allow them to create a different shapes. So let's think about the approach that you will be using, the object-oriented approach that you will be using to represent those shapes in your code internally. So we know that every single shape that is going to be rendered in this drawing tool will have a shape, will be extending from the shape class, and this shape class is going to have some common properties, which are basically common to all of the shapes that are being rendered on the screen, and they are the x coordinate, the y coordinate, or maybe the color, right? And let's also think of the shapes that will be extending this class, right? So I'll say that we have a shape called circle, and we know that the circle class is going to have its own x coordinate, y coordinate, so it's simply going to inherit from this base class, shape base class, right? And then of course, other than that, the circle is also going to have its own properties such as the radius, and let's say that we also have another class, and right in this time this class is going to be the square class, and the square class is going to have its own height and width. Now this is something that the circle class does not have, and this is the property that is unique to the square class, right? Okay, so now so we know we have a scenario where we have a hierarchy of shapes, and the base class is the shape class. Now we know that our editor is going to allow us to create multiple shapes based on these classes. But what if I just want to copy and paste the shape? Maybe if I've already rendered a circle with some specific radius value and with some x coordinate and y coordinate value and some color, and I want most of those properties, but I just want to change the radius. So what would you do? What would you do? You will basically creating a new object, a new instance of this circle, right? But how do you make sure that you can basically clone the properties without ever needing to instantiate the constructor of this circle class? Now this is a problem, right? And let's try to code this and see, can we really do this using TypeScript? Okay, so let's just I will just open up my editor and try to implement this scenario using TypeScript. Okay, so we know that we will be having a class called shape, so I'm just going to go ahead and create a shape class, and the shape class is going to have some x coordinates, so I'm just going to call this a number so it's going to be of type number, the y coordinate, and we know that we have a color, so this color is going to be of string, and we're also going to have a constructor. This constructor is going to receive the x, y, and color property, and then finally we will just say this dot x equals x, this dot y equals y, and this dot color equals color, right? And Finally, we will just say that we have another class called circle, right? And the circle class is going to extend from the shape class. Perfect. Now, this circle, what does it have to do? It has to obviously call the constructor, and since we are now extending from the shape class, we also need to call the super constructor. And since the super constructor receives the x, y coordinate and the color of the shape, we also need to pass it from the child class. So we will also be receiving the x, y, and color, and we will be simply relaying these properties to the parent class, just like that. And that's pretty much it. And since we also know that this circle class also going to have its own properties, such as maybe the radius, so I'm just going to say radius equals a number. So radius is a number, we know, and also we're just going to copy and paste the same class, and we know that everything is going to be same for the square class except for some of the properties, right? So the square class is going to have its own height and width, so I'm just going to add those height and width properties in this class, right? And everything else is going to be same, we're not going to change anything else. Okay, now if I want to create a new circle or a new square object in my program, how would I do that? Well, it's pretty simple. You will just say let circle, I'll just call it C1 equals new circle. We'll just call the new keyword, which essentially just means that we are instantiating a new object of a particular class. We're creating a new instance of this class. And what do we need to pass into this constructor? We need to pass in the x coordinate, y coordinate, and the color. So I'll just do that. I'll just say it's going to be on 12 x coordinate and 12 y coordinate, and the color of the circle is going to be red. Perfect. And then we also need to set some other properties of the circle, which are the radius. So the radius, let's suppose, is 23. I'm just going to pick any random number here. Okay. Now, if I want to basically create the clone of this circle, if I want to basically copy and paste this circle, what would I do? I have to basically take in all these properties that are already assigned to the circle and assign them separately to the new circle. So the common approach in any object-oriented programming language would be to basically say let C2 equals a new circle, right? And since we need the properties of the old circle, we will just say C1 dot x, C2, C1 dot y, and then C1 dot color, right? And similarly, if I want to set the radius of this new circle to the same radius that was uh, the radius of the original circle that we created, right? So I'll just say C1 dot radius. So this would be how you would normally clone an object, right? But this also has a lot of pitfalls to it, right? It has a lot of drawbacks. This approach. Imagine that your circle class keeps growing, and maybe it has the metadata or of like 50 or 60 properties. Now you would need to pass in all those properties manually, and this is only going to just increase this only going to increase the lines of code that you write, and this approach is not good because you are essentially going to face the cost of initialization. And imagine that this x property and y property was not just decided immediately, but there was some complex operation that goes inside this constructor, and then finally these properties are computed based on that operation. So now when you're calling this constructor method again and again, the cost of initialization, the cost of that operation is a lot, and you want to avoid that because you're just cloning an object, right? So you don't have to call this constructor object again and again. How can we do that? Now this is exactly where the prototype pattern is applicable. We need to create some sort of a cloning logic inside this shape class, so that all the circles and squares, whenever we want to clone them, we just need to call the clone method, and it's going to essentially help us create a new copy without ever needing to instantiate the constructors of these child classes, right? All right. With that being with our problem being clear, with our problem being established, now let's see what the prototype pattern has for us. Okay, so I'm just going to quickly go back to my screen here, and I'm just going to get rid of this diagram because we really don't need this diagram. I'll just put this above right there. Okay, now what does the prototype pattern suggest us to do? So I'm just going to go ahead and bring in a class diagram here, and let's just create something called the prototype. So now this is the prototype pattern, okay? Now I'll just say that we are creating something called a prototype interface, okay? Now this prototype interface has not a lot of things inside it. It's just an interface with um, with the definition, with just a declaration of the method called clone. Now this method is only going to be mentioned here, but the actual implementation of this method is obviously going to be in the concrete classes that implement this interface, right? So we will do that in a moment. But what does this concrete what would this interface clone method do? Well, it's just going to return us the prototype object. Okay, for now this is our interface, and what do we need to do? We need to create concrete implementations of this clone method. So let's create another class, and we're going to call this class concrete prototype. All right, and maybe I'll just move it right beneath this interface. And we know that this concrete class is going to implement this prototype, and since it's now implementing this prototype, it also has to implement all the methods that are inside this prototype interface, right? So we only have one method, that is the clone method. So we are going to create a public implementation of this clone method, and this clone method is going to return us something called the prototype object. Okay, so what have we done here? We have basically implemented this interface. So now whenever we are trying to implement the concrete, whenever we were trying to create the instance of the concrete prototype class, we know that we have a clone method available. And essentially all the cloning stuff, all the cloning operations, copying the object from and its properties from one place to another, to another object or the target object, will be done by this clone method. So most of the challenges that you will be facing in implementing the prototype pattern will be associated with this clone method, and we will take a look at into this, like what are the problems that we'll be facing. Okay, so now if the client code, if the client object, maybe if you wanted to create maybe a new concrete prototype. So if on the client side, on the client code, if you want to create a new prototype from this concrete prototype class, what we will be doing is we will be referring to this clone method, right? And we know that all the objects that are being created using this concrete prototype will support some implementation of the clone method. So the prototype pattern is basically providing us with an interface, with a cloning interface, from which we can basically avoid creating or duplicating the code, and just use the clone method to basically create and copy the new object and all its properties. So all the logic of cloning will depend on the scenario that you have, the type of object you have. Maybe you have the nested objects inside an object, or maybe you have nested arrays, or maybe you just have the primitive values. So how do you make sure that you copy each and every single value or the nested values inside another object? Well, all of that is going to go inside this clone implementation, this clone method. So let's now map this design pattern into our original problem, our original shapes problem. Okay, so I'm just going to go back to our editor again, and now let's implement this clone method, right? So we know that we need to implement an interface. So I'm just going to implement the interface, and I'm just going to call this interface prototype, right? Okay, that's pretty simple. Okay, what do we need to do? What do we need to do next? Well, we need to create a clone method declaration. We're just defining the method here. We're not actually providing any implementation of this method in this interface, right? So we're just going to say that this clone method is going to return us the prototype typed object. Okay, what's next? Well, we know that the shape class is going to be implementing this interface, and the reason why I want to do this is um, because all the circle and the square objects will be inheriting the shape class. So this method is going to be available in all these classes by default. So that's why I am implementing this interface inside this parent class, right? And it makes more sense, right? It's all logical. Now we need to also provide an implementation of this clone method, and this is where the main challenge comes up. How do you copy all the basic properties such as the x coordinate, the y coordinate, and the color property from this shape class into this new object? I mean, we can't just say return this return new shape. If we do this, we're essentially calling the constructor. We don't want this. We want to be able to copy whatever is inside the instance of this constructor. So whenever we are creating an instance, we have the access of that instance within our class, and that is using the this keyword, right? We have the this keyword. But if we just return the this keyword from our clone method, it's going to just return the reference of the original object. We want to make a copy of it. Now every language, if you're coding in C sharp, or maybe if you're implementing this pattern in Java, or if you're implementing this pattern in Python, all classes provide some sort of a built-in methods for cloning an object, or basically shallow copying or deep copying a particular object. So in JavaScript or in TypeScript, we have something called the object.create. So what we can do is we can say let shape clone equals object dot create. Again, now this is available to us from the JavaScript web APIs, and we can just call this method and pass in the this reference. So the this right here is pointing to the current instance of this shape class. So whatever instance we have of the shape class, this is going to be referencing to that instance, which means all the current properties and values that are passed from the constructor object are also going to be within this object. So the create method, the object.create, will actually create a new copy of our object without and also avoid the constructor call. So we have essentially created a very simple way of basically simulating the prototype pattern here, right? And this is not going to um, be called again, right? Now we can just simply return the shape clone directly, and that's pretty much it. What we have just done here is we have created a clone method, we've provided an implementation of this clone method, and now all the classes that inherit this shape class will automatically have access to this clone method. And since we are talking about the this here, we know that inside the circle class, the this will be referencing to the circle instance, and if you're talking about the square class, the this in that clone, the this in the circle class will be referencing to the instances of the squares. Okay, so now here we were trying to create the new circle using the new keyword. We don't have to do this anymore, right? What we can do here is we can say c1 dot clone. That's it. And if you now try to log all of these properties, maybe if I just say console.log c1 dot x coordinate and c1 dot y coordinate, and we want to do the same for C2, and we're expecting that the coordinates of this will be same, right? We know that we have, so that this clone method is going to return us the same properties. But of course, since this clone method is going to return us the prototype is essentially corresponding to this interface right here, which does not have access to all these properties, right? So that's why we are not able to access these properties directly. So what we can do is maybe we can just have a separate implementation of the clone method inside the circle class, and maybe change this prototype to circle so that we can access all the radius, x, y, and color properties through the dot syntax here. But I will just try to add a workaround for this right now and just add an any. So let's see if this actually logs the properties for us on the console, right? So see, let's see what we get. Okay, so as you can see, the x coordinate and the y coordinate of our C1 was basically copied to C2, and this is exactly why we have both of those coordinates being logged to the console. And if I just try to change maybe the coordinate of C2 to maybe x equals 24 and C2 dot y equals 25, and let's see if that makes any difference. So So as you can see now that we have both of these properties being logged. And also I'll just try to log this property below um, this initialization or this assignment, because I want to make sure that these properties are not being updated by reference. We know that there's a problem in JavaScript, or this is a problem that in almost all languages, that if you are basically referencing to the same object, it's essentially going to update the properties of the original object and not the new object. But we need to make sure, we need to basically verify that a new object is being created. So this should log two different properties onto the console. So let's see if that is the case. mm, let's wait for this. Yeah, so we have different properties, which means that we are successfully creating the clones for our circle. Perfect. And we can do the same for the square object, and we can just basically now, since we have the C2, we have the access, so we can actually just go ahead and, let's suppose we want to clone the C2 object into another object. We could just say C3 equals C2 dot clone. And yeah, so we can just now, yeah, like keep cloning, and we will always have the access to the clone method, since it's part of the interface that is being implemented by the parent class, right? So this is essentially what the clone method is going to do. Now there's a problem. Okay, there's a problem here. We obviously have all the shallow level properties available in our current implementation. We don't have any nested objects here, but let's introduce a challenge here. Okay, and this is essentially what you should be very careful of when you are implementing the prototype pattern. Let's say we have a class called metadata, and this metadata is going to have some sort of ID, and maybe this metadata is also going to have some sort of a border property. Our shapes have some border property, so I will say that the border width is going to be stored in this property. So now what I'm trying to do here is I'm going to say that each shape is going to have some metadata, right? So the metadata is essentially going to be of type metadata class, and we need to instantiate this metadata now, right? So now let's suppose we set the c1 dot metadata dot border equals maybe 3, and c1 dot metadata dot id equals maybe 44. Okay, so I'm just assigning some random values here. But now see what happens when I try to update the values of maybe c2 dot metadata dot um, border equals 4, right? So we are expecting the metadata to be also copied, since we are making a copy of our entire instance here, right? So let's see what happens if we do this, right? And I'll just remove the C3 for a moment here, and we will also just get rid of this. So we know that the metadata property, the border property inside the metadata object of C1 has 3, and the metadata and border object and the metadata object of the border property of the C2 instance has 4. So if I try to log both of them onto the console, I'll just say c1.metadata.border, and similarly I'll just copy this same line and change this to c2. Let's see what we get. So we are expecting the answer to be 3 and 4, right? But look what happens when I basically log this to the console. Okay, so we have some errors. Apparently it says that we cannot set the properties. Oh, because we haven't instantiated the metadata here. So we first need to also instantiate this. So I will just say this dot metadata equals new metadata. So this is necessary because this is a class, so we need an instance for that. And let's run this again. Now you can see that we are getting the 4 in both of those properties. What just happened? I mean, the C1, the circle 1, had the border 3, but the C2, when I changed and assigned the 4 to the border of C2, it also updated the border of C3, of C1. And the problem here is that we are now updating the values by reference, which means the metadata object right here is pointing to the same metadata or data object in the memory, and it's only one instance. So we also need to create a copy of the nested level objects, and this is essentially the problem that has been discussed in the Gang of Four book, and it is called the shallow copying and deep copying. So what we just did here is called the shallow copying. So what we are doing here, I'm just going to add a comment here, and it is called the shallow copying of the instance, right? So when we're shallow copying the instances, what we're doing is all the primitives that we have available, such as this x coordinate, y coordinate, and color property, and maybe in the circle we also have a primitive property called radius or the height and width. All of them are the primitive properties. They're not they're not non-primitives, right? They're not nested objects or arrays. So when it comes to the cases of arrays and objects, we need to explicitly copy and paste. We need to explicitly assign the nested values in those objects, into our new object. So right here we are trying to clone the shape, and we're just copying this, all these properties, and here it's also copying this metadata, but in the value of this metadata, it's basically passing the reference of the original object, and it's not making a copy of this metadata object. So how can we do that? Well, we can just say shape clone dot metadata equals object dot create this dot metadata. So now this is going to actually fix the problem for us. Why? Because now we are actually creating a new copy of the metadata object as well. So now all the properties inside this metadata object, all the current properties of this metadata object will be copied to this metadata, but when we change or update the property of the new object, it's not going to change the older object by reference, because now we have two different memory blocks being assigned to each object, each clone, right? So now let's try to run this code and see if this actually is true, and this is actually is the case. So now let's just run this code and see what we get. Yeah, so now we can see that we have both properties as we expect them. They are working as expected, and this fixes the problem of the shallow copying, right? We essentially shallow copied our object. So now whenever you're trying to implement the clone method, you have to be very careful, in a sense that when you have nested objects or arrays in your parent object, you need to also shallow copy these objects, or maybe you can implement a deep clone method where it recursively traverses through all the nested objects and arrays and tries to find out all the primitives inside those and then makes a copy. So this is essentially what the prototype pattern is all about, and I just demonstrated a simple implementation of this in JavaScript. So hopefully this made sense to you, and if it did, don't forget to like and subscribe to my channel for more such videos, because I'll be uploading and posting more videos related to design patterns and design principles. So yeah, that's it for this video. See you in the next one.